Hi, welcome to learn the algorithm with me together. Today, let's take a look at the 543 diameter of binary tree. And what is this problem talking about? We'll be given the root of a binary tree and then return the length of the diameter of the tree. And what is the diameter of the tree? It is the length of the longest path between any two nodes in a tree, and this path may or may not pass through the root. And what is the length of the path between two nodes? It is represented by the numbers of the edges between the two nodes. So now let's take a look at a more at first is this first example to understand the concept first. Like we have this tree here, and we can calculate any two nodes to get the longest path. For example, we can have these two nodes, and the path of them is 2, right? But of course, it's not the longest, because if we are going to like this node, the path between them will be like 1, 2, 3, at least 3, right? Or probably we can calculate like these two nodes, and their length, the path of them will be 1, 2, and 2. So usually the longest path will be between like two leaf nodes. So what is the leaf node? Leaf nodes is the nodes they don't have any children anymore. It's just this one, 4, 5, 3. They don't have any children. So usually they are the longest. And now the point is, for this example, the longest path is from the 4 to 3, right? But what if like the tree become more complicated? For example, or let's keep it like the tree, it turns out like to be 1, 2, 4. Probably it has like 5 here and 3, and we continue to have the nodes here like 6, 7, something like that, 8, 9, 10. And now what is the longest path? Definitely like these two, they only have 3 here. 4, 2, 3, they only have 3. But now 10 to 7 could be have like 1, 2, 3, 4, 5. They have 5. Or like these two, 4 to 10, they will be like 1, 2, 3, 4, 5. 5 as well. So these two could be also the longest. And how we solve this problem? Like as a machine to calculate that. And now let's go back. We can probably remove this node to make the 4 and 10 will be the longest one. And now we are consider like how we break this big problem into the smallest problem. Like for example, we only have these 3 nodes here. Now let's move it like this here. Like if we only have like 3 nodes, what will we do? We will definitely choose, or probably we can say just have 3 nodes here. And as the root node, probably I will start to ask my left child like, hey, so what is the longest path you have, right? And for the node 2, he doesn't know it, and he will also definitely try to ask his child, like, hey, for what is your longest path, right? So for the 4, he doesn't have any child. Of course, he can ask, but he doesn't have any child, and so go back. It only has now or maybe 0 and ask the right, and because it's now also return 0. So then because he doesn't have any ages, when he goes back, it will just return these only ages and will return just 1 to his parent node. And for the parent, he asks the left child, and he also will ask the right child, and the right child will also continue to ask his left child, and let his left child also return like 1. And then the 5 also asks his right child and continue to ask. And for the rightmost child, he will just return back the value, like, yeah, I only have 1, and then go back, like tell it like, now I'm not only have 1, because at his level he already got 1, and when he goes back, he also update this 1, and he will return like 2. And then he also goes back and tell him like, yeah, I have 3 now. So now he will combine like his left and right. We can say, or probably we can say here, for the current node, he will just return his left answer and right answer. Like, yeah, I had the longest one is 4, right? And then he also goes back to another point is, if we only consider this from the right side, it should not be the maximum is 4. It should be only like the longest side. Yep, so now actually it will just return back the value of which is the longest one. It's left side or right side, and then +1. So this is what we are telling our parents, like, which one is larger, not his longest one, right? So it will just return the max value, and then +1, because 1 is this new orange, the go up levels age is 1, so it will update like return 4. And then now for the node 2, it will continue to compare his left child and right child, which is greater. So she will return like the right side have 4, and 4 + 1, it will turns out to be 5. So this is how we do. But also this is what we are telling our parents, like, the longest side I got. But at my current level, I also calculate the current level's length, whether it is the maximum length. So I will have like a variable to keep track of it. Once, probably smaller. So once the current sum is larger than the maximum length, I'll just update it. And also before that, we got the left from our node left, right? And also the right got from the node right. And that's what we do for our current level, like. And when we stop is, as I said, if the node is null, right? Or probably we can say if the node is the leaf node, we can start to return 1 to tell our parents, like if the node is leaf, then we can return 1 because I'm the leaf, and I tell my parents like, yeah, hey, there's only one edge from my side, and if there's a null node on our left side or right side, we only go if the left is not null. Or the right is not none. Right. So this is how we will do using probably DFS we call. And what is the time complexity? So for the time complexity, because we have to traverse all the nodes, so it will be ON. N means the number of the nodes. And about the space, well, because we use the stacks, so it's OH, and H means the height of the tree. This is height of the tree. Probably we can just merge it here. Because we will go to each level as far as we can and go to the depth. So we'll use the stack to keep track of the state. So that's the space complexity. And I believe that is how I will solve this problem. And now let's move to the coding part. So as I said, we will use another function to call this because this integer we return is already the result. But from this DFS, we are returning the maximum length of only one side. So we'll have another DFS function to help us treat node. And we can have the node here. So if the node is the leaf, then we'll just return 1. Else, if the left side is not null, we will start to go to DFS to the left side, and if the node right is not null, then we will go to the nodes right as well. Okay. Or probably like, because we also need to compare the left and right, and so probably we can just continue to say like if the node is null, we can return 0, and then for the result we are like return the max, like from the left and also from the right, which one is larger, right? And then after getting it, we +1 to tell our parents. And for the main part, we will, alright, so yeah, we cannot do this because we also need to calculate the maximum size. So here we need to have the int left, max left, equals to 0 now, so max left equal here, and max right great. And now we have to update our max length, like whether it's greater than current sum of the max left and max right, and then we return the max length and no less is left. Oh yeah, this is the length max. You can see here which one is larger, and +1. And of course we can have the integer max length here, and then we can return. So after we run DFS, we can return the max length here. So now let's run it. Cool, all the test cases pass, and let's submit it. Yeah. So this is how I will solve this problem. Like, we are using the DFS like to ask each level, are you first is at current level, or you got max length, and also for each level it will ask is left child and right child, which is your max length. That's what we're gonna do using the DFS. So yeah, that's it. If you think this video helped you, please give me a thumbs up. That'll be a great encouragement for me. And thanks for watching. See you at next video. Bye.